The only force not aligned with our coordinate system is mg. It makes an angle of theta prime with the rotated y-axis. So we need to figure out what theta prime is. Now let's look at this red triangle. We know that the angle of the incline is theta, the red triangle is a right triangle, and the other angle we'll call alpha. So since angles in a triangle have to add up to 180 degrees, and that bottom left angle is 90 degrees, it means that alpha plus theta equals 90. Now we also know that the y-axis is perpendicular to our incline. So theta prime plus alpha must also equal 90. But we already showed that alpha plus theta equals 90. So we can conclude that theta prime is exactly the same as theta. The gravitational force has components into the surface and along the surface, and it will affect the force equations in both cases. So we will need to resolve it into its x and y components along the rotated axes. Like we did earlier in dynamics, we're going to have to resolve this into components and use sine and cosine. So sine is opposite over hypotenuse, and since fx is opposite our angle theta, sine theta is equal to fx over mg, so fx is equal to mg sine theta. So this is the component of mg on the x-axis, and this will accelerate the box down the incline. Next, we need to solve for the y component of the gravitational force. The y component is adjacent to the angle, so the cosine of our angle is equal to the y component divided by mg. So the y component is equal to mg cosine theta. So this is the component along the y-axis and will be equal to the normal force. So now the gravitational force has been resolved into x and y components along our rotated axes. The y component is mg cosine theta, and the x component is mg sine theta. How is this different from when we would resolve forces along the non-rotated coordinate system, where the x-axis was horizontal and the y-axis was vertical? In the non-rotated coordinate system, we were used to seeing force and acceleration components using the cosine function in the x direction and the sine function in the y direction. That's reversed now.